So something a little different for today. I've got to make a crucifix IRL that's small enough to be 3D printed. So I'm going to take a look at essentially how effective that will be as a 3D print. So we're going to make the crucifix in Blender and then export that to Creality's Slicer to then see how much or how well that will 3D print. So it'll give us all the options that we need once we get the file in there. So in Blender we need to make the crucifix. Let's just reorganize the interface a little bit. General, layout, let's call this TikTok 3D, and then we want another one, layout, TikTok outliner. Is that right? That's right, isn't it? Rearrange the views. Join areas. Join areas. Join areas. So that's a 3D view. TikTok outliner. Join areas. Join areas. Right, so first thing we need to do is set up the scene properties for the 3D printer. So we're using millimeters, which means we have to be in scene properties, units, and we have to set the length to millimeters. We then need to set the unit scale to 0.01, and that's that. And then in the 3D view, that's changed the view, and it's also sidebar, it's also changed the properties or the way that Blender then looks at our object. So instead of being a 2 by 2 by 2 meter block, we've now got one that's 20 millimeters, which coincidentally is the size that we actually need, but it's made the grid absolutely massive relative to our cube. So we need to go into, we need to be in viewport overlays and change the scale to match the scaling that we applied for the units. So 0.01. So we're now 20 millimeters. Well, so that means each grid or block, viewpoint top, each block is 10 millimeters or 1 centimeter. So we've got a cube that is 2 by 2 centimeters or 20 by 20 millimeters. Right, so let's just hide the sidebar. Don't need to do anything else. Need to edit mode. Going to leave the origin point at the base there. Make sure everything is selected. Select all. Use the widget, hold control, snap to the grid, and move that up. Face, grab that top face, and we need to extrude this. So we can use the tool just to make this easier to see or understand. So use the widget. So extrude up, hold control, snap to the grid. So that's 1 unit. Snaps of the grid, that's 2 units, and then a third, so that's 4 units high in total. double check our orientation. So viewpoint front. So we want the side, and then we want unit that way and units that way. So that is literally our simple crucifix. So switch back to the move widget just to cancel the, or disable the tool. Let's just save this. File, save as. We need to be 3D printer, crucifix, brackets 1. So save as. Now for 3D printing, we could export this as it currently is, but it's questionable whether doing something as simple as this in terms of the number of faces. So how many faces is that? So select all. Let's turn on viewport overlays, statistics. That will give us our surface count for our object. So 26 faces. So it's questionable whether this would produce a functional STL file for printing. So we can test this, because whether we can use this or not will probably depend A, on the 3D printer, and B, the slicer that's going to be used to prep the file, to prep the STL for 3D printing. So we can export this, so let's do that. Drop out of into object mode. Let's just outliner, enable wireframe just to make it easier to see what's going on. So wireframe, so object properties, wireframe. So if we select none, we can see the wireframe of our object. So that's our very simple object. So let's just save an iteration of this. File, save increment. So if you're using Blender 4.2 LTS and above, you'll get your save increment option, which you can then automatically save an increment of the file so that you don't have to keep worrying about that. So save increment. Now we need to export this to STL. So select our object, file, export, and we want STL. So file, export, STL. We'll get the file dialog as per usual. I don't know if we've got enough space on screen for this. So browse to the location where you're going to save the file. Give the file a name if you need to, and in the properties, we don't necessarily need to do anything here per se, except we might need to fiddle with the scale, but we'll check that. Apply modifiers. We don't have any modifiers, so that's okay. And let's just export the STL. Export. So that's exported. Now we can import that into Creality or Creality's slicer program. So open, browse to our STL file. There it is. That's tiny. It's only 3 kilobytes. Let's smush that in a little bit. So 3 kilobytes. So select, open. And this is going to be tiny because of the scale difference between Blender. So even though we have Blender set up to use millimeters to match Creality and the printer, there is a scale difference in terms of the physical size of the mesh, not the units of measurement. So depending on the slicer, we can make some adjustments to that so we don't have to keep fiddling in Blender with our meshes and the scaling. So there should be an option in your slicer to scale, move, rotate, and do all sorts of other things. So we want scale, make this 1000. So that is our object scaled up to the correct size. And we can check that, at least in Creality, down at the bottom here. That's our size. So that's our object. We need to prep this or check it to see how it'll work. So slice, preview, and we'll see that that has worked. But so this is one of the tricky things about 3D printing. Although you can pretty much print anything, the amount of filament that you use is going to depend on whether your object is going to need some support in order for it to be printed. Now, you can add that support in Blender, but again, it's best really to do that in your slicer, because the way that the slicers do all of this stuff, these fills that are necessary to support the arms, it might differ depending on the slicer that's being used. So we want to check our options, or edit our options. So there are our options. So supports is active. If we disable that, it's going to remove the supports, but it'll probably, we'll need to re-slice that. Let's just close that and then just work through. So this is the preview of what's going to be printed. We don't need this to be a solid object. So what the slicer is going to do is this randomized pattern on the inside to optimize the amount of material that's going to be used for the print. And we can adjust that in our settings. So if we check the settings again, we don't necessarily need a huge amount of infill. Let's try gradual infill. See what that does. Right, so we can see, well, what we can see from this is, let's just check that. That is probably not going to print because it's an unsupported structure. So as the printer head is traveling along this direction, it's going to be squeezing out medium, and basically it'll just fall because there's nothing to support it. So we do need supports. But what we're doing right now is just taking a look at how our object is going to be printed and how the fill is going to work. So with gradual fill set, it's got very little at the bottom, and then more towards the top of the arms. And this is pretty much where most of your medium is going to be used up, is doing the filling. Same with the top as well. So how long is that going to take? That's going to take 2 hours. And this is relatively accurate. So 2.5 hours. So if we add the supports, reslice, that's doubled essentially the amount of time it's going to take. So that's using up a huge amount of medium as well, 10 meters. So that's, well, 19 grams, 6 meters, 6.5 meters versus 10.5 meters. So that's a significant enough a difference. But what we can do to solve this problem where we need supports here, and that's basically wasting quite a bit of medium, what we can do is rotate, and it should snap. Yes, it does. Reslice. So that is now our object, and it's using slightly more medium, and it's going to take a few minutes more, but let's get the properties open again. That's okay. You don't need the supports, but our preview so it's going to it's that top layer that's going to be the thing that uses up most of our material. So let's try a different fill. Reslice. Two hours, 15 minutes. See, that looks like it's going to work, but I can almost guarantee that it won't, because this is wide enough to cause issues for the 3D printer. Although, having said that, it did work for some dice that were basically the same size, 2x2 cubes, 2x2x2 cubes. So but what we have discovered from this is that we can indeed just use a very simple shape with 26 faces, because otherwise we would have to use modifiers, add subdivision surface. Let's keep that at 1 for the moment. Otherwise we use subdivision surface, and that basically means we have to do some editing. This is a relatively simple planar. So we can add undo because when you start doing this, increases the file size quite significantly. But that's how we get our sharp edges. Increase our subdivisions. So now we're dealing with something that's got 96,000 faces. So if we save that, file, save increment, export, file, export, STL, this is number 3. Our settings are okay. Export STL. We'll save this to file. So this is the low res version. Save to file. So that's our G code. Save. So we'll bring in the file that we just created. Oh no, we need to save the project first. Save project. Save. Save. Now we can, new project. Yep. Open. Number 3. Open. Same process again. So there is our little tiny cross at the center of the build plate. Scale 1000. There it is, upscaled. And interestingly, the red areas tell us where the mesh is unsupported. So select, rotate, flatten. So now we have no red areas because we don't have anything unsupported. So slice. And it basically gives us the same information. So it doesn't really make any difference whether we use a subdivision, well, in this particular example anyway, it doesn't make any difference whether we use a subdivided mesh versus just a very simple 26 face mesh. So it's always worth doing your different versions and checking. So let's preview that. So that's our very top layer. And it's basically the same thing. Same amount of time and the same amount of filament. So all we need to do now is, right, save this to file. So that's G code number 3. And then all we'd need to do is print these up, transfer them to the printer and then print them up. So that was just a quick look at what would an IRL project look like, or how long would it take, because making this in IRL would actually take longer than it would to print this. And of course, once it's printed, you then have to deal with all the striations of the print head and the medium, which was relatively straightforward compared to whatever material this is made out of IRL. Because if it's wood, it's going to chip out on the edges, which you then have to deal with. And obviously you've got the join between the arms and the body. Those have to be dealt with, versus just printing it. So that'll be the next thing. We'll just post some updates with the object printed. So that was just a quick, interesting exercise just to see what it would be like, how much it would cost essentially in resources to print this crucifix instead of having to make it IRL. And of course, because we can print this, we can put a number of them on the build plate. So that's another option. Multiply selected models. How many do we get on there? Maybe 4? Oh, can't get all the objects on the build plate. Yeah, we're maxing out the build plate. So let's make some adjustments to the placement of these. Slice that. So that is going to take pretty much 6 hours, 7 hours to print 3 of those. So now this is where it gets interesting from a math perspective, so to speak. Because, oh, there's the 4th one. Get rid of that. Delete. So redo that. Yeah, it's still 6-7 hours. So that's where this gets interesting with the math. Because how many IRL objects, crucifixes in this case, how many of those could you make in 7 hours versus the 3 in the same time? So that's where this gets interesting from the perspective of multiple units. Let's just save that. So that is interesting. Save file. 3B. And save the project. B. So how much time are you actually saving? Granted, you are getting finished products that only need finishing from the point of view of maybe some filler to deal with the printer head, the striations of the medium. But how many, let's say if you were making these out of wood, how many bits of wood could you cut up and assemble in 7 hours versus just having these 3 printed in the same amount of time? Are you really saving time? It was an interesting exercise, just seeing how well a simple form like this translates into being 3D printed versus being made IRL. Because if you were batching them, I would imagine that you would be able to make more than 3 in 7 hours IRL. So call it quits there. That was just an interesting exercise, and maybe we'll do some more of these interesting projects with the 3D staff to see just how the truth about 3D printing. That's what this is, really. 3D printing is sold as this savior, essentially, of creative output. But, did we save that to file? But it's not, oh yes we did. It's not necessarily optimal for doing repetitious stuff because it takes a long time for it to print whatever it is that you need to print. Interesting.